Hi students, in this video, we're going to learn how to do prime factorization and using the concepts to find the LCM and HCF of two given numbers. Do get ready a pen and some papers and practice along with me. Let's start off by understanding what are prime numbers. Basically, prime numbers have only two different factors. One and itself. So therefore, the smallest prime number we can think of is 2 because 2 can be written as 2 times 1. So the two factors are 1 at itself. Therefore, 2 is the smallest prime number. 3 can be expressed as 3 times 1. So it has two different factors, 3 and 1. 4 is not a prime number. Why is that so? Because 4 can be expressed as 1 times 4, can also be expressed as 2 times 2, right? So if you look at this number 4, we can see that it has three different factors, 1, 2, and 4. So therefore, 4 is not a prime number. Also, we have to take note that the number 1, okay, it's equals to 1 times 1. So it has only one factor. So therefore, 1 is not a prime number 2. So to summarize, the smallest prime will start with 2, followed by 3, 5, 7, 11, 13, 17, etc. So on and so forth. Alright, so the next part is we need to learn how to find the prime factorization of, let's say, this number 54. There are two methods you can use to find the prime factorization of this number. The first method is called the ladder method. And this is how you do it. You start off by dividing 54 with the smallest possible prime number. In this case, we can divide it by the number 2. Right. And 27 can be divided by the next prime number, that's 3. And you keep doing until you have 1 at the last row. So therefore, 54 can be written as 2 times 3 times 3 times 3. And this 3 times 3 times 3, we can stack it up to become 3 to the power of 3. So that is called the ladder method. The second method, it's called the tree diagram or the tree method. It's called the branching method, or you can also call it that way when you branch it up into two different prime factors, 2 and 27. And 27 can be branched off as 3 and 9, and 9 can be branched off as 3 and 3. Right, so basically it stopped once you manage to get a prime number. So 54, it's equals to 2 times 3 times 3 times 3. So again, we can stack up it to be 2 times 3 to the power of 3. So this is what it means by prime factorization. Right, so the next thing is that we're going to use this prime factorization to find the LCM and HCF of two numbers. So using prime factorization, find the LCM and HCF of 54, and let's say the number 15 or 30. Okay, let's change it to 30. All right, so we already found the prime factorization for 54, which is basically 2 times 3 to the power of 3, right? So we're going to do either use the ladder method or the branching method to find the prime factorization for 30. So 30 can be divided by the smallest prime number, that's 2, that gives you 15. 15 can be divided by 3. And once we have 1 here, we stopped. So therefore, 30 can be written as 2 times 3 times 5. So the next thing is that how do we use this prime factorization to find LCM and HCF? So we need to do a comparison. So this is quite, what they call that, methodologically, as in we need to align the prime factors, the same prime factors, as one column, right? So this is what I mean. I'm going to align the 2 and 2 as one column because we're going to do some comparison. All right, so therefore you need to put all these prime numbers of different power together as one column. So that will be 3. Okay, and you see that for 54, I do not have 5 as the prime factors, so I'm going to replace it with 1. Okay, because you can't replace it with 0. 0 times whatever will give you 0. So the smallest number, which does not change, basically does not change the number itself, is 1. 54 is 1 times 54, right? If you multiply it with 1, it will not change the original number. And so we have a factor 5 for the number 30. All right, so this is how we do it. And then the next thing is to find the LCM. We will choose the biggest number of the 2 prime factors. So in this case here, 2 and 2, we have to take 2. 3 cubed and 3, the bigger number is 3 cubed. 1 and 5, the bigger number is 5. So that will be the LCM for this number 54 and 30. Then to find the HCF, we will get the smallest of the 2 number. So 2 and 2, obviously you have to choose 2 because that is the only number you have. 3 cubed and 3, you choose 3. 1 and 5, you choose 1. So 2 times 3 times 1, which is 6, will be the HCF for 54 and 30. All right, so how do we verify that this method is correct? Okay, if you were to, I'm going to show it to you. Another way of doing, which is very, very rather tedious, where we do not use prime factorization. If you were to recall how we do the multiples, so the multiples of 54 would be 54. 54 times 1 is 54. 54 times 2, 108. And then you take 54 times 3, 162. 54 times 4, 216. So on and so forth. And then you go on to find the multiples of 30, which is 30, 60, 180, 540. Okay, sorry, I don't have a calculator with me. That's why I'm doing this. Okay, and you keep doing. Right, I think I make a mistake here. This is 60, 90, 90, 30 times 4, 120, 30 times 5, 150, times 6 is 180, times 7, 210, times 8, times 9. Yeah, and finally you see that that is your lowest common multiple, right? And then after finding that, you will have to use the ladder method to express it as prime factorization. So therefore, what I provided here, it's an easier way to find the prime factorizations in using prime factorization to find the LCM of 54 and 30 using this method. Okay, right. So likewise, for if you want to use find the higher common factor for 54 and 30, you can list out all the factors for 54, factors for 30, and from there you can find the highest common factor for both of this number, which again it's very tedious. So therefore, using prime factorization, it's a quick and efficient way, all right, to help you accomplish this mission. All right, let's do one questions from the N-levels papers. Okay, you're given that 125,000 can be expressed as prime factorization to the power of A times 5 to the power of B. And it can also be expressed as 50 cubed. And the prime factorizations for 50 is 2 times 5 squared. Right? So not to worry, it seems like there's a lot of information to process. We start off by writing 125 by using this information, which is equals to 50 cubed, right? And we're going to replace this 50 with this information. So that will give us bracket. You have to bracket it. Anytime you're dealing with two numbers, here, can you see we have two numbers here, 2 and 5 squared. You have to bracket it. Okay, right. So you can, all right, what does 3 cubed means to you? It means 3 times 3 times 3, right? So if give a generic one, A cubed, it means A times A times A. So what this means is 2 times 5 to the power of 2 times 2 times 5 to the power of 2 times another one. And we're going to stack all the 2's up. So you will have 2 to the power of 3. You're going to stack all your 5 ups. And you will have 5 to the power of 2 plus 2 plus 2, 1, 2, 3, 4, 6 of them. Okay? And with that, we can write it down. This is 2 to the power of 3 times 5 to the power of 6. And you can do a comparison. You'll see that A is equals to 3 and B is equals to 6. Okay? So this part here, you don't really have to do any ladder method. It's the prime factorization is already done for you. So for part B also, it's done for you. So all we need to do is just to do some grouping. All right, do some grouping and do some comparison. Right, so I don't have a prime factors 2 here, so I'm going to replace it with 1. I have 5 to the power of 3. I have a 7. I have a 3 squared. And for 9800, I don't have a 3 squared, so I replace it with 1. All right, then now we can find your HCF. So we take the smallest of the two primed factors. So 2 cubed and 1, smallest is 1. 5 squared and 5 cubed, smallest is 5 squared. 7 squared and 7, 7 means 7 to the power 1, so the smallest one is 7. 1 and 3 squared, smallest one is 1. So we're supposed to write a product of the prime factors. So that will be 5 squared times 7. Okay, times means product. Prime factors, 5 is a prime number, 5 squared is a prime factor, 7 is also a prime number. So that's how we do it. Right, so to find the LCM, just choose the biggest of the two numbers. So 2 cubed and 1, we choose 2 cubed. 5 squared and 5 cubed, we choose 5 cubed. 7 squared and 7 to the power 1, we choose 7 squared. 1 and 3 squared, we choose 3 squared. So that will be the LCM for the two numbers there. So that marks the end of this video. Happy learning.